Welcome to the 2020 A.W. Beatty Back to School Night, virtual edition. I'm Mike Purucker, Mr. P to my students, who are in the Robotics Engineering Technology program. Before providing an overview of the Robotics Engineering Technology program, or RET as I refer to it for the rest of this presentation, brief background on me. After high school, I studied electrical engineering and received a bachelor's degree. I then decided to enroll in the University of Pittsburgh's bioengineering program, and while I was there, I did research with the Rehabilitation Science and Technology Department. Some of my research led to automation of certain procedures, which eventually, no surprise, ended up working with robots. On this screen, you can see the two robots I worked with the majority of my time in my professional career. I worked with the Conair group, which later the automation group splintered off into Sapro America. And the robots that we worked most with at the time of my employment were the Sapro robot on the right, the blue and silver one, and the yellow FANUC robot on the left. The FANUC has an articulating arm action, so it moves more like a human arm, whereas the Sapro is Cartesian, meaning it moves along more the XYZ coordinates, and it is designed to quickly enter and exit an injection molding machine. Now that's more than enough about me. I want to talk about the amazing students that we have in the RET program. Here's a slide from a year ago where early on in the school year we just did a random design competition among pairs or trios of students. And the winning design for the morning class was it was a paper tower, basically, with office supplies, tape and paper clips, etc. This is the picture from the morning class winner, and you can just get a basic overview of the entire room as it was a year ago. Typical, mildly chaotic, and definitely a little bit messy, but that's where a lot of the learning happens. Students who are successful in the RET program often have a similar profile. Strong at math, good mechanical skills, like to solve problems, can follow complex procedures, have a very good attention to detail. They're curious about the science behind how things work. They like to tinker with things. They can both work in a group, but also can shine individually by being self-motivated and self-disciplined. Every Beatty program has a required list of tasks or skills that students are supposed to master when enrolled in the program. For the RET program, those competencies, as we call them, are predominantly in electronics. And Pennsylvania requires that I teach specifically 99 competencies to students enrolled in RET. This figure is a very simplified version of the electronics curriculum in the RET program. First year, first semester students begin in the center circle with components, Ohm's law, and DC circuits. They expand to include digital and AC electronics in their second semester. And during a second and possible third year, they explore semiconductors like a diode and a transistor, power and power supplies, op amps, motors, and electromagnetism. An electronics foundation is a good start, but many other skills are needed to work with robotics and mechatronics. 3D modeling is a major part of project work in the classroom. SolidWorks and Fusion are two different platforms that students have access to while they are in the RET program. Both allow students to extensively model their own designs and fine-tune other people's designs depending on the need. In the 3D printer corner of the room, we have a Stratasys F270, that's the large unit on the right, that lists for somewhere in the $30,000 to $35,000 range. On the rolling table with the butcher block top is a U-print that's about 10 years old. We use that more for prototypes or less demanding 3D prints. And on the far left, the wooden unit is a replicator, an original replicator that I don't even know how old it is, but I've had students been able to rejuvenate it and get it working again. In the middle, where there's some stuff piled on top of it, is an SCA tank that allows 3D printed parts with certain support material to be dissolved. Students must follow safety rules and pass safety tests before they can use this equipment. 3D printing is an additive process. One layer is built at a time, and eventually the 3D modeled part appears. Subtractive manufacturing, like the CNC mill shown here, work the opposite way. One layer of product is removed at a time, but you still end up with the same 3D designed part present. We just received this unit, and we're very excited to finally have a CNC mill in the RET room. It's a matter of time before we can get it scheduled to be installed, be trained on it, and start using it, but that is something we are looking to have happen as soon as possible. About 1/3 of the room is dedicated to fabrication equipment, as shown in this picture. From a chop saw to a table saw, a grinder, a sander, and a bandsaw. There are a number of very powerful tools we have similar to a wood or metal shop. Students must follow safety guidelines and pass safety tests to use this equipment, but we use it in a lot of different ways, principally during first robotics, but anytime we need to make a custom sized part for whatever project we're working on, we'll be using these tools. Some coding skills are taught to RET students as well. They're not emphasized as strenuously as electronics or the mechanical and fabrication skills, but a basic understanding of how software works, and especially because Python is involved with the Loco, Robo, Drone, and ExtremeBot, and it's the #1 language students entering college should learn, we feel it's a good introduction to the idea of coding. Now, if students want to go deeper, they can. But the basic idea is to have a certain level of knowledge that's enough to be familiar or literate with coding and programming. The Loco Drone and Loco Robo ExtremeBot, shown on the right side of the screen, use the Python language, but they also use a simpler block-style language, as does the MBot, and the Parallax Bowie bot is kind of a hybrid, and we're starting to fade it out of our usage. Another area of growth for the program is to begin doing more with Raspberry Pis and Arduinos. On the left is the Raspberry Pi, on the right is an Arduino Uno, and there are already examples of using these microcontrollers in the classroom, but I intend to expand the direct teaching of how to use these more and make sure that students are familiar with what is becoming really extended beyond the hobby realm to something that's very useful to make small devices work well, whether it's just for fun or even in industry. I can't show you any of the projects live this year, but I can show you what has been done in the past and what we're planning to do in the future. The traffic light, done a couple years ago, used an Arduino to control a normal traffic light, and basically was assigned so that students could have it respond to remote controls in a way that I specified. The QR code on the right, that's not an actual working code, but it represents a system that is almost up to speed to allow students to go in and out of the room using QR codes and logging their attendance in the room versus out of the room. On the left, you see the FindyBot 3000. Students saw this and thought it would be fun to try to replicate what somebody else has already done. Basically, it's a database that you set up and then can be used to tell you where certain things are stored in the various compartments. You might say, show me all the power supplies, and the lights in the front of each of those compartments will light up to show you all the different power supply storage locations. Bottom right is another long-term project that we make some progress to and then kind of falls off to the wayside, but it's a long-term goal to have an automated walking taco machine just because. I can't entirely explain it, but the kids sure like it. Putting it all together, this figure represents the RET program as a whole. The electronics foundation is the center point. Beyond that, students move into 3D modeling and printing, fabrication, and Arduino projects, all of their own choosing. And to get a little more involved, might use a Raspberry Pi for a project, eventually use the CNC mill once it's up and running, do some coding and some room projects, such as seen on the previous slide. FIRST Robotics can be of limited involvement or maximal involvement depending on the student's interest, but it is something that allows all of these different elements to come together in a real-world scenario. So what about FIRST Robotics? It just kind of appeared on that last slide, right? Well, we've been doing FIRST Robotics so this will be our 15th year. As you see, the slide mentions 14 years, and there's a robot from 2019 that was very successful. Unfortunately, we didn't have a chance to follow up that success because of the pandemic and the cancellations that were caused by it. Last year's robot is shown here. Unfortunately, this 2020 Beatty Bulldog did not get the chance to compete. Normally, I would be telling you of the opportunities to immediately start and work with the group of students that are part of the FIRST Robotics team, team number 2051, if you saw on the previous slide. For now, those plans are on hold until we see the way forward in our current situation. I will say that last year, from September through March, over 40 students contributed over 2,500 hours to the team, more than 2,000 of which were involved with building the robot. The competitions are a lot of fun, but there's more to FIRST Robotics than just robots competing against each other. We offer FIRST Robotics to the students because it gives them a potential glimpse of what a career would be like in a field related to what we do in the RET program. Being part of the FIRST Robotics team is practically like being in a small business that makes robots. And you can see that beyond that real-world experience, the people who participate, as you see on the slide, report significant gains in very important skills like communication, conflict resolution, time management, problem solving. And they're much more likely to pursue an engineering or STEM field. Something new this year is the ability for students to earn micro-certifications through the ARM Institute CMU SMART program. The electrical, fabrication, mechanical, software, and robotics integration badges that are seen on screen can each be earned eventually by the students. I must be certified first, then I can begin certifying students. The electrical foundations should be definitely done this year and possibly a second, but it will probably be a couple years before students could attempt to earn all 5 micro-certifications. Students who successfully complete the RET program can earn up to 20 college credits. On screen you see it's Cal U, that's 20. There are about a dozen other schools that range from 4 to 14 credits. Students can also earn scholarship money either through FIRST Robotics or by individual scholarships that are brought to them by our school counselors, Mrs. Zielinski and Mrs. Goodyear. Most RET students are interested in being an engineer, a robotics technician, or working somewhere in a manufacturing environment, perhaps as a machinist or an assembler, electrician. Most of these jobs require additional education beyond high school, but there are some limited opportunities available directly after high school in Beatty. To get the additional education needed for many of these jobs, students may attend a 4-year university, 2-year college or technical school, or they may just go to a vocational school. A lot of good options are listed, but there are others, many others, not shown. It's impossible to fully describe what happens in the Robotics Engineering Technology program in a video based on a PowerPoint presentation. However, I hope that I've done justice to the students who are currently in the program and the students who have previously been in the program so that we can bring in the next generation of amazing students to continue to build on what has been going on in the RET program now for the past 5 years. Thank you. I hope you enjoyed our virtual tour of the RET program.